Why Python? Means Python being a kind of programming language, and there are many programming languages. If I see a structural programming language, then there are C, I mean primarily, there were like Pascal earlier, and if I see, means we'll have a discussion like where Python stands, why Python. If I see kind of object-oriented programming languages, then we have C++, we have Java, and if we enter into scripting kind of, then we have Perl, and we have Python. Then why we should kind of, why we think that Python is a language that is kind of present and it is future. So what are the kind of features that we get in Python that it lacks in other language? So that is generally it is in discussion. Is Python doesn't look like a very big programming language the way C++ and these languages are, but still there are reasons why kind of Python is unmatchable. Means there is no kind of parallel to Python. Okay, so let's see kind of what feature it provides. Like if we see kind of object-oriented, then the main thing that we get in object-oriented is polymorphism. So C++ provide polymorphism, means runtime you can kind of through the same interface you can change the actual data. So that is the polymorphism. So C++ provides polymorphism, and on top of polymorphism we get design pattern kind of thing. So we can do many more. Then C++ provide lot of mechanism that we can extend it, like reference counting, and destructor would get called when reference counting becomes 0. It is anyway there in Python. So if someone is working in Python, then no need to do any invention, nothing is required. Everything is available in Python. Means full-fledged polymorphism, to all design patterns, to reference counting. So there is no destructor there. So in Python it is a kind of it get I think it's destroyed, or it gets freed. It's cleanup code get called automatically when refresh code reaches 0. So that is, I think it is del item or something like that. So that is the function that get called. So we have to call del. Reference count get decreased. Anything, whatever the feature we think on top of C++, everything by default it is provided in Python. So then if we get kind of all the high class feature, polymorphism to reference counting to automatic kind of destruction, and so those kind of things, then it makes sense to use Python. Okay, but what is something like I can, okay, if I am getting in C++, then anyway I am getting in Python, then anyway by hook and crook I can get in Python also. Then why I should use Python? Means anyway I know C++ very well. Then why I should use Python? Okay, the biggest thing that we see in Python is there is nothing hidden. Means it's a very big thing. There is nothing hidden. Everything is explicit. Okay, so it's like whatever we do in Python, so everything is data structure based. Okay, like if I go for or if I start with the C, then I have a file and I declare something as static or constant, then it has internal file linkage. Or if I want it to be seen in other files, then I have to use external. It is kind of something that is implicit, means is hidden. I don't know, means I just mug up or just remember, okay, external means external, and then const, and static means internal. And if I kind of compile it or link it in the binary, it will come to this section of the binary and those kind of things. So I have to remember. Means in C, I have to remember a lot of things. So things are implicit. Means I'm not talking about memory allocation and free. That is anyway headache, but still it is headache that we kind of think, we kind of remember so many things. Constant means this, and then static means that, and this and that. So that is not there. If I come to C++, same story. Here also. If I have a class and if I derive from other class, then base class would enter into the object layout of the derived class. So if there are three classes, if I have three classes, they derive from the same base class would enter into the three derived class object and they become part of it. Then there is a virtual keyword. What is meaning of virtual? Then I have to remember. Then there is a, like virtual, there is a static keyword. If I use static, means it would go like static means it will become a kind of a class variable, static function. And there is an implicit this point that I have to remember that this means this is no way it is going to work now. Means the softwares are becoming so complex that programmer is not in a situation to think about. Means if we see the programming or any lifestyle, things works on reliability. If I am standing or sitting on a layer and then I am writing code on next layer, then I should not worry about this. Means there should not be any defect here. Then layer by layer, if I go up, then down the layer, there should not be any defect. So that is taken into granted. I cannot just think that if any kind of functionality problem is coming, then suddenly I would think that, oh sorry, I think instead of virtual, I should have made it static or static virtual, I don't know, so many things. So I mean, I don't want to emphasize it. So then static means that this pointer I don't have to, where is this pointer, where it is getting stored, and what is coming to the picture. If I derive from something, then base class comes inside it, and then if I use a static keyword, then it will means completely clumsy. Means it's not usable in now. Like if I go for machine learning or OpenGL 3D graphic, itself it is a big headache. On top of it, I don't have any guts to go and check the reference counting and so many items. So not possible. Means we need something on top of it we can sit where things are available and error. Okay. So Python is a data structure based language. Everything is a data structure. If I have a class, then if I define a class, then there is a data structure that get in C term, if I say that get malloc, means I receive a new data structure that is a class. If I have an object, that is a new data structure. If I have a module, then that is a new data structure. Everything is a data structure. So if I want to kind of do something with the module, I just need to fetch the data structure. Module data, wherever it is, I don't bother. Either I cannot get it or I get it. If I get it, then I can operate on the data structure. If I have a class, if I kind of instantiate a class object, not class instance object, through type function, type built-in function, or I define the class, I get the class object. Okay, it's completely explicit. Means the fundamentals in Python is completely explicit. Means there is no pointer or reference and free and malloc. Means it's a headache savior, and then we don't have a kind of a polymorphism bottleneck, nothing. Everything is clean, but still the biggest power of the Python is being an explicit language. If I have a kind of self pointer, or I would rather say the self reference as the first parameter in the kind of a method of a class, method of a user defined function, then it is implicitly called, if the user defined function is called against the instance, No worry, means someone can call explicitly also. Okay, class and then instance as the first parameter. Means there is nothing. Okay, so everything is kind of explicit in Python. So if I get to just fetch the data structure, it's done. Okay, so if I have a kind of a function in C++ class that is belongs to a class, how I can access the function? I cannot access the function. Means I don't know. Means there would be some binary way. But here, if I have a user-defined, if I say method, the term method comes, and if I have a class, and there is a function inside the class, and then I want to access the function. Simple class dot function, because class is a data structure, function is a data structure. Since function behaves like attribute of a class data structure, class dot function. Simple. Okay, and if I do method dot function, then internally it does some binding, and then it creates a method object. But these kind of implicit things are minimum. Means I can do explicitly also. Amazing. So Python must be used in a sense that debugging time to development time, everything is like just plowing through agriculture field. Means it's a kind of very easy. Okay, so it should be used, and then there is explicit distinction between objects. When we go for data structure creation, then we have kind of explicit differences between the kind of class object instance or class object data structure. Then we have meta class. So if I try to kind of fetch any attribute of a class object, then it reaches its class like meta class. So meta class is a class of class. I mean, in C++, if I have an instance, then it will read its class method. Then here, if I have a class object, a data structure, its class is meta class. So meta class is the class of the class, and then class is the class of the instance. But everything is data structure. There is nothing implicit that I am writing something and it is external or it is static, and then so keywords are very less. I believe it is 20 or something like that. So if I write any piece of code in Python and I want to access it, just try to get the data. That's it. Nothing to worry. It is private, protected, public, and data hiding, and then security, and then it is in that file. So it should use external, and then static to this class, and then it is belongs to this class, not to the instance, because it's static. Since it's static, then this pointer will not be there, and then there will not be entry into vtable entry, and then vtable they will have a thumb, and then at runtime it will. There is nothing. You have if you have a type, then it must be instantiated. There will be a data structure. Class has different data structure. Instance has different data structure. If I derive from a class, then class data structure and instance data structure, there are two things. Nothing is going to come inside anywhere. So if I derive from a class, another class, then this class data structure is different. This class data structure is different. If I need to access a method in this class, it is not available. It will go to the another data structure or another data structure. It would refer there. Same data structure would be referred by other classes. There is nothing implicit going inside or something like that. So there will be n number of data structure that is available. The way we instantiate, there is nothing implicitly get instantiated. Module, it's another data structure. Function, it's another data structure. Anyway, we have kind of we have mutable and then unmutable data structure. So everything is data structure. Just have access to the data structure, then you know the its type, means what are the field available. Then you can get the way. Amazing.